Hello guys, today we're going to be going over lesson 3, the trig ratios with the Pythagorean theorem. So our learning target is you should be able to find the sine, cosine, and tangent ratios of an acute angle in a right triangle. So in order to be successful today, you need to be able to use the Pythagorean theorem to find a missing side of a triangle. And then we can label the sides as the hypotenuse, opposite, and adjacent sides. And then you should be able to know the sine, cosine, and tangent ratio definitions, and then be able to simplify the sine, cosine, tangent ratios when necessary. So if you remember to our lesson 6.1, we had to use the Pythagorean theorem to find the missing measurement. And so if you recall, the Pythagorean theorem is a squared plus b squared equals c squared, and our c is always going to be the one across the 90-degree angle, and then our a and the b, it doesn't really matter which one you call which. So a squared plus b is 7 squared equals 25 squared. And so if we do here, a squared plus 49 equals 25 squared, I believe is 625. Let me double check that, but 25 squared is 625. And then I'm trying to get the a squared by itself, so then we have to subtract 49 on each side, leaving us with a squared equals 625 minus 49 leaves us with 576. And then the square root of 576 is actually 24. So our a, if I take the square root of each side, gives us 24. Because the square root cancel out the squared, leaving us with 24. So the missing side of the triangle is now 24 over here. Okay. And so in today's lesson, we're going to have to be able to use sine, cosine, and tangent, but we're going to have a missing side. And so we're going to have to use Pythagorean theorem to find the missing side first, and then be able to label the sides of the triangle. The hypotenuse, if you recall, is always across from the right angle. The side opposite is the side across from the angle, and the side adjacent is the side next to the angle. And then our trig ratios, remember, is a ratio of two sides or a fraction of two sides of a right triangle. And the three primary ratios are sine, cosine, and tangent, and we reviewed these yesterday. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And so to remember these, we use the mnemonic SOHCAHTOA. So is sine over opposite over hypotenuse, and I can write that as so is O over H. And then ka is cosine adjacent over hypotenuse. So ka. And then our tangent is TOA, which is the opposite over the adjacent side. So TOA for tangent. Okay, so if we take a look at our first example here, notice I have a missing side. My missing side is actually the hypotenuse. It's across the 90 degrees. So my hypotenuse really is the missing side. And then I'm asked to find the sine of A, cosine of A, and tangent of A. That means my A is the reference angle, which would then mean 9 would be the opposite side. And then 12 would be the adjacent side. Okay. And so then I have to use the Pythagorean theorem to find the hypotenuse. So if you remember, the hypotenuse is going to be the same thing as our C. And then the 9 or the 12 doesn't really matter which one is which. So we would do a squared plus b squared equals c squared. So we would use 9 squared plus 12 squared equals c squared. Because that's my missing side is the hypotenuse, so that would be c. 9 squared is 81 plus 144 is my 12 squared. So if I add those together, that would give me, let me do that really quick. 81 plus 144 would give us 225 for my c squared. And if I take the square root of 225, that's actually going to end up being 15. So now I know that my hypotenuse is 15. And so then I can use SOHCAHTOA now that I have my missing side. SOHCAHTOA to help us find the trig ratios. Sine is opposite over adjacent, so the opposite side is 9. Sorry, I said adjacent, but hypotenuse. The hypotenuse side is 15, and then I want to check if I can simplify. So I noticed both of those can be divided by 3, so 9 divided by 3 is 3. 15 divided by 3 is 5. And then cosine is so adjacent over hypotenuse, or 12 over 15. And again, I can divide those by 3, which would be 4 over 5. And then tangent is TOA, so opposite over adjacent, 9 over 12, which again, we can simplify by 3, would be 3/4. Okay, so you want to make sure that you simplify the fractions as much as possible. Moving on to page 6, our next example here, we have the missing side is up there, and I want to check the angle that we're focusing on. Our reference angle is D, so then D is my reference angle, so across the angle D is 2, so that would be my opposite side. Across the 90-degree angle is the hypotenuse, which means I am actually missing the adjacent side. And so again, I have to use the Pythagorean theorem. A squared plus b squared equals c squared. And so I always want to focus on my c, which again, if you remember, is going to be the hypotenuse. So in this case, that's the 4. And the 2 and the missing side doesn't matter really what I call, which one is a, which one is b. So 2 squared plus b squared is equal to 4 squared. And so then I get 4 plus b squared equals 16. Then we subtract 4 on each side, leaving us with b squared equals 12. And if I take the square root of 12, that would leave us here, if you recall, we have to get the perfect squares, 1, 4, 9, 16. The ones smaller than 12 would just basically be 4 and 9. And then 4 times 3 would give us 12. So then my b would be 2 root 3. So my adjacent side is now 2 root 3. So now that I have the missing side, we can use SOHCAHTOA to find the trig ratios. Okay, so sine is opposite, which is 2, over hypotenuse, which is 4. And again, that would reduce down to 1/2, dividing both of those by 2. Cosine is so adjacent over hypotenuse would be 2 root 3 over 4. And then I can simplify. 2 goes into itself 1 time and into 4 2 times. So then this would simplify down to the square root of 3 over 2. Then my tangent is TOA. So that would be O over A TOA. So 2 over 2 root 3. And again, the 2 goes into itself once. So then this simplifies down to 1 over root 3. And then we rationalize it by multiplying top and bottom by root 3. So I would get root 3 over 3 as my solution for that one. Okay. All right, you guys can go ahead and do the practice problems on your own. And then we're going to go ahead and do the next example here. So one more time, I'm looking for the reference angle first. So F is the reference angle. So now I'm up here. So angle F, we put an arc. Across the angle is the opposite side. Across the 90 degrees is the hypotenuse, leaving us with the adjacent as the missing side. And then again, I want to focus on Pythagorean theorem. A squared plus b squared equals c squared. And across the 90 is always my c. And then the other two doesn't really matter which one is which. So 7 squared plus b squared equals c squared, which is 9. 9 squared. So 7 squared is 49, and 9 squared is 81. Subtracting 49 on either side leave us with b squared is equal to, what is that? 81 minus 49 leaves us with 32. And so then if I take the square root of b squared, leaves us with the square root of 16 times the square root of 2, which simplifies to 4 root 2. So the adjacent side is 4 root 2. And then we can use our SOHCAHTOA to find the missing sides. I'm sorry, to find the trig ratios. SOHCAHTOA. So sine, again, is opposite over hypotenuse. So 7 over 9. And I can't simplify that one. Adjacent over hypotenuse is CA. Oops, where did it go? Down here. Sorry, guys. So CA is the adjacent over the hypotenuse. So 4 root 2 over 9. And I can't simplify the 4 over 9, so it just would be my final answer. And then tangent is TOA, so TOA. So 7 over 4 root 2. And the only thing I can't have in the denominator is the square root of 2, and I can't simplify the 4 into 7. So remember, I showed you guys an example like this yesterday. You would take this and only multiply by the root 2. So that would leave us with 7 root 2. And then this root 2 times root 2 would be 2. So then I get 4 times 2, which is 8 in the denominator. So my final answer would be 7 root 2 over 8. Okay. And you guys can go ahead and do the last practice problem. And then once you're ready, then you guys can do the assignment